Quick question. Why does your Wi-Fi router demand that you use numbers and symbols in your password? Like, why can't password 123 just be password? The answer isn't what you think. It's not about making it harder to guess. It's actually about something called encryption. And by the end of this video, you're going to understand the real math that keeps your data safe. And honestly, it'll change how you think about security forever. So here's what we're covering today. The actual reason complexity matters, how encryption uses your password to scramble data, and why a 12-character password with random symbols is exponentially stronger than you probably realize. I'll show you the number that proves it at around the 4-minute mark. Let's start with the threat. When someone tries to crack your Wi-Fi password, they're not sitting there typing guesses like in the movies. They're using software that can test millions, sometimes billions, of password combinations per second. Here's the thing. The software doesn't need to understand your password. It just needs to find the right string of characters that, when run through an encryption algorithm, produces the same scrambled result as your actual password. That scrambled result is called a hash. Now, if your password is just lowercase letters, 26 possible characters, a modern computer can test every single combination up to 8 characters long in less than a day. But add uppercase letters, that jumps to 52 possible characters. Add numbers, now you're at 62. Add symbols, you hit 94 possible characters per position. And here's what most people don't realize. The difficulty doesn't just add up, it multiplies. A 12-character password with mixed case, numbers, and symbols isn't twice as hard to crack as a simple one. It's trillions of times harder. Literally. But that's not actually why your router is demanding complexity. That's just the side benefit. The real reason your Wi-Fi password needs complexity is about how modern encryption works. When you connect to your Wi-Fi, your password isn't sent to the router in plain English. Instead, it's put through a mathematical function, an algorithm that scrambles it. That algorithm is designed to be one way. You can turn my password 93 into gibberish, but you can't turn the gibberish back into my password 93. That's actually the whole point. The router stores the scrambled version, not the original. When you try to connect, your device scrambles whatever password you type and compares it to the stored scrambled version. If they match, you're in. If they don't, you're locked out. The router never has to know your actual password. So why does complexity matter then? Because of something called the key space. Key space is a fancy term for how many possible passwords could theoretically exist. With simple passwords, the key space is small. With complex ones, it's massive. Here's the number I promised you earlier. A simple 8-character password made of just lowercase letters has a key space of about 200 trillion combinations. Sounds huge, right? A modern GPU, a graphics processor designed for fast calculations, can test all of those in under an hour. But add just one number and one symbol to that same length? Now you're looking at a key space of 2.7 quadrillion combinations. That same GPU would need over a year. Now push it to 12 characters with full complexity? You're talking septillion combinations. We're beyond years. We're into longer than the universe has existed territory. And here's what's wild. The encryption algorithm itself doesn't care about your password strength. It works the same way whether you type password or turpixel thun through traki 92. The algorithm is the engine. Your password's complexity is the fuel. More complexity means more possible inputs, which means an attacker can't just iterate through them all before the heat death of the universe. You might think, okay, so if cracking my password would take longer than the universe exists, why do I need to update my password every 90 days? Why does my bank keep nagging me? Here's the truth. Password resets aren't usually about protecting you from brute force attacks. They're about reducing damage if your password leaks in a data breach. If a hacker gets a database of millions of scrambled passwords, they can't reverse engineer them into the original. But they can use something called a rainbow table, a pre-calculated list of common passwords and their hashes. If your password is common, it's in that table somewhere. So complexity isn't just about making brute force attacks harder, it's about not being in those pre-calculated tables. My password 123 is probably in there. Turpixel Thunthurster key 92? Almost certainly not. That's why your router is demanding it. That's why everything's demanding it. And that's why, honestly, the best password is one that's long, random, and includes mixed case, numbers, and symbols. So what should you actually do with this information? First, stop trying to create clever passwords. Password isn't secure just because you swapped letters for numbers. Use a password manager instead. Let it generate truly random 16-plus character passwords. You don't have to remember them, and they're mathematically impossible to crack. Second, stop reusing passwords. Every single account should have a different one. Why? Because if one site gets breached, hackers don't get just that one account. They try your email and password everywhere. A password manager makes this effortless. Third, enable two-factor authentication wherever it's available. This is the real hero of modern security. Even if your password gets compromised, the attacker still can't get in without your phone or authenticator app. Your Wi-Fi password needs numbers and symbols because the math demands it. That complexity isn't arbitrary. It's a direct response to how encryption works and how fast modern computers can calculate. Every additional character type, every additional length multiplies the computational cost exponentially. It's not paranoia, it's mathematics. If you want to try any of the tools mentioned in this video, password managers, authenticator apps, I've linked everything in the description below. This stuff is genuinely fascinating once you understand what's actually happening under the hood. If you found this breakdown useful, drop a comment letting me know what tech concept confuses you most. I'm always looking for the next why to answer. And if you're new here, subscribe. We break down the tech everyone uses, but nobody understands, every week. Thanks for watching.